We know how to take a resultant vector and make it into x and y components by using trig functions such as sine and cosine. We also know how to find resultant vectors if we have the other sides using Pythagorean theorem. Now we need to learn how to draw a resultant vector. There are two methods. The first one is the parallelogram method. Parallelograms are opposite sides are parallel. To make opposite sides parallel, we're going to shift vectors either up, down, right, or left with the same magnitude and the same direction. We represent a vector using an arrow. The back of the arrow is known as the tail. The front of the arrow is known as the tip. The tip will give you the direction of the arrow. Once you shift your vectors either up, down, right, or left, the resultant vector will start from the tails to the tips. So in this first example, we have a vector going to the east. So I draw my vector going to the east. We have a vector going north. So from the origin, I'm going to make it go north. Using the parallelogram, what I'm going to do is I'm going to take this east vector, I'm shifting it up parallel to its original vector in same magnitude and direction. I'm going to repeat the process for my north vector. My resultant will start at the tail, so all the tails will meet, to the tip. So this is the direction of my resultant. So all the tails are together and all the tips are together. In my second example, I have an arrow going northeast. I have another arrow going southeast. Using the parallelogram, I'm going to take the northeast arrow and I'm going to shift it parallel to its original, same length and same direction. I'm going to take the southeast vector and I'm going to do the same thing, same length and direction. My resultant starts from the tail and ends at the tips. So this is my R. So here are my tails, here are my tips. So if I look at these two vectors again, I have a vector going southwest, then I have another vector that is going northwest. So I'm going to draw my southwest vector, my northwest vector. And what I'm going to do is I'm going to shift it, same length. So I'm going to take this northwest vector and I'm going to shift it down, same angle, same direction, same magnitude. I'm going to take my southwest vector and I'm going to shift it up, same magnitude and direction. My resultant starts at the tip and they all meet at the heads. This is the direction of my resultant. This one, the last example, it goes to the south and then it goes to the west. I'm going to shift the west vector down, same length and same direction. I'm going to shift the south vector over, same length and direction. So the length is the magnitude. My resultant starts from the tails to the tips. This is my R. If you draw your vector and you accidentally draw it in this direction as your resultant, if you notice, the magnitude will be the same, but your direction will be completely wrong. So remember, from tails to tips. The first method of drawing resultant vector is very effective when you have two vectors. When you have multiple vectors, the parallelogram method is too difficult. So we use something called the tail to tip method. You start with any vector using correct magnitude and direction. So you draw your first vector. After you draw your first vector, let's say it goes to the east, I start my second vector from the tip of that first vector. So if my second vector goes south, I start from the tip of the first vector and draw it south. My resultant will start from the tail to the tips. And this is my R. And so if you have more than one vector, you keep on doing tail tip, and the resultant will be from the tail of the first vector to the tip of the last vector. So in this example, I'm going to start with the first vector. I'm going to draw it. This is my original starting point, the tail. From the tip of the first vector, I'm going to draw my second vector, this one, going southeast. My resultant is going to be from the tail to the tip. And if we draw this using the parallelogram method, it will be similar. So if I do my northeast and then I go southeast, I shift it up, shift it down, same direction and magnitude from the tails to the tip. If you notice, the R is the same. If I look at this second example, I am going south. I'm going to draw the south first. From the tip of the south, I am going to go to the west. So tail, tip, tail, tail, tip, tail, tip. Resultant goes from the original tail to the tip. And it doesn't matter which vector you start with. I could start with the west vector first. So if I start with the west vector, I draw it. This is my tail of the first vector to the tip. At the tip of the first vector, I'm going to go directly down. So my resultant is going to go from the original tail to the tip of the last vector. If you notice, my R is the same. So this one, we have three vectors. So if I start with a parallelogram, I can't make all three sides parallel. So you want to use the tail to tip method. So it doesn't matter which vector you start with. I'm going to start with the first vector. Let's label this A, B, C. So I'm going to go southeast. Then I'm going to do the second vector, B. So from the tip of the second vector, I'm going to go west. So this is my first vector A, this is my second vector B, and then from the tip of my second vector, I'm going to draw my vector C. My resultant will start from the tail of the first vector to the tip of the last vector. So this is my direction. This is my R. I could repeat this starting with vector B. If I start with B, I'm going to go west. So that's my B vector. From the tip of B, I could draw my A or draw my C. I'm going to draw my A. So if I draw my A, it's going to look like this. From the tip of my second vector, I'm going to draw my C. Just going to look like this. So from the origin, which is B, I'm going to go to the tip. And this is my R. And if I actually measure the length and the angles correctly, they will look almost identical, my R. The last example, I'm going to start with the C vector. From the tip of the C, I'm going to draw my A. And from A, I'm going to draw my B. My resultant goes from the tail of the first vector to the tip of my last vector, and this is my R. If you notice, my R's look very similar.